Hello everyone, today we'll talk about the problem double a number represented as a linked list. It's quite self-explanatory looking at the title. We're given a non-negative integer without leading zeros represented as a linked list, so every digit is a single node. And we have to return twice that number, right? That number times 2, or that number added to itself. There are many solutions to this problem. Some of them are more general, some of them are more specific to this particular operation. Today I'll show you the iterative solution that is very similar to just adding two numbers represented as linked lists. So that would be the most general approach and probably the easiest to come up with. I'll do it iteratively because yesterday I've shown you a recursive solution to a linked list problem, so it's nice to also see some iterative approaches. It's also possible to solve this problem recursively quite easily. And of course, since this is a very particular operation, this doubling, we can make some observations at the beginning that will make solving this particular version quite easy. In general, what we want to do, as you know probably from school, when you have some numbers and you want to add them together, and for instance here you get a 0 and you have this 1 that you have to carry to the next column, and it is exactly called a carry. So this is 3 plus 7 is 10, plus 1 is 11. Here you write 1, here you have a carry. You write 1, here you have a carry. Here you write again 1. You have a carry, and so you have to add another position. Right? So this is the summation. And this is the only tricky thing in this problem, is that sometimes we have to add another node. So the way we're going to implement it iteratively is first to also iteratively implement reverse in a list. Then we're going to just add all the digits together, so double the digits, keep track of the carry, and if at the end we run out of digits but we still have a carry, we just add another node at the end, and then we reverse that list again. Right? So essentially here, since we have those numbers given left to right, but we have to progress right to left, we have to reverse them. We reverse them, add them together, then reverse them again. Another solution that would be recursive would be to first add together everything other than the first digit and get some carry perhaps, either by having this number be 10 or more, or by remembering that we have a carry. And in that case we also have to, when adding those two numbers together, care about the carry. And after all that, if we still have the carry, we create a new node, we point its next pointer to what we've got by summing all those numbers, and that is the result. So if we do it by recursion, it's still, well, it will still in a way reverse the list, and it will reverse the list more in memory, so it would have worse memory complexity. The same if we use something like a stack. And there are of course also other solutions for this specific operation that allow us to go through the list only once, especially considering, for instance, the observation that we can look at the first digit and immediately tell if we have to add another node or not. Since if the first digit is 4 or less, we don't have to add another node at the beginning, but if it's more than 4, then we certainly have to add that one additional node. So we know if you have to add that node, and then we can go in a smart way through all the positions, look perhaps at the next position, and update them accordingly. But we're not going to think about these solutions today. I'll just show you the most basic approach, which is iterative reversal of the list and iterative calculation of the sum. This is the most similar one to just adding two numbers represented as linked lists. Okay, so as I mentioned, the basic algorithm is we reverse the list, we calculate the sum, we reverse the list again. So let's start by talking about list reversal. And one way to implement reversing a list iteratively is, first of all, if there's nothing to do, then we just return what we've been given. So if the list is empty or it has only one element, then it is its own reverse. Otherwise, we have to go through all the elements and change their pointers such that at the end the list is reversed. So in essence, if we have a node pointing to a next node, as is usual in a linked list, then, and this one perhaps points to, let's say, some null value. Then at the end we want this one to point to null value, so to a none in Python. This one to point to this one to point to this one, and we have to return this one as a new head of the linked list. So we can go through those pairs of subsequent elements and reverse their next pointers in place. You just also have to remember to always not forget any node so that we can progress through the list. And in that situation, we have to remember, of course, our head. We also have to remember the previous value that we've seen before. So at the beginning, it is a null pointer. And in general, since we are reversing the list, we want the next pointer of our head to point to the previous node, or in case head was the first node, to point to none. First of all, since we want to modify head next, we have to remember head next in another variable so as not to lose it. So we remember what is after head, then we change head to point to the previous node, and then we have to make one step forward. So the previous node is now head, and the node that we're currently looking at is that node that was after head in our list. And if we do all that, then we have to return the last node that we actually looked at and changed, which is stored in prev as the previous node. By the way, reversing a list is also a problem of its own on LeetCode, so if you want to see if you can come up with this and implement this yourself, or if you want to try to implement it recursively or in some other way, then feel free to do so. It's probably called something like reverse a linked list. And let's now, since we have this subroutine to reverse a list, look at the rest of the algorithm. And it's very simple. We start at the head. We have to keep the head in mind because at the end we have to return it. So we use another variable. And we just go through every element. We double it, so we add it to itself. If we have a carry, at the beginning we don't, we also have to increment it by 1. So it's exactly the process that we've seen before. And now the carry would be 0 if this number is less than 10. And if that number is more than 1, then the carry is still equal to 1. And of course, if there is a carry, then our sum is 10 or more, so we have to get rid of the first tens digit. Right? So now v is the correct digit for this position, so we just put it at that position. We remember if we have a carry. And at the end, if we do not have any more digits, but we still have a carry, then we have to create a new node equal to 1. So this is the case where we have to add another node. It will always be node with value of 1. And we go to the next node as long as possible. And at the end, of course, since we reversed it in order to perform the operations, we have to reverse it again and return it, and that is the whole solution. This is very general. It's very similar to what we would do if we wanted to just add two linked lists together. They can, of course, have then different lengths, but those digits will still be aligned because their last digit will be added. The last digit of the first list and the second list are the ones that should be added together. Just there will also be another case here. If we progress through one of the lists and the other list is already run out, then we just have to add the carry to the value that we've seen here. So this comes from the first list, this comes from the second list, and some of those might be 0 if we run out of any list. But this is the most general solution. Of course, this is an example of an iterative solution. In general, iterative solutions to list problems will have those weird calculations involving pointers, pretty hard to wrap your head around, no pun intended. But here there are no, at least, pointer problems in the very last part, right, the addition part. So at least we have that. Feel free to solve this problem in any of the previous ways I mentioned, or maybe come up with a new, unique way of solving it. But in general, linked lists are pretty interesting and pretty like a brain teaser, right? So some people like them, some people don't. I tend to not like them. But yeah, if we get a problem, we have to solve it.